Japanese urban neighborhoods carry generations of history, rooted in a long tradition of wooden architecture. From temples and shrines to tightly connected homes, these districts reflect both cultural heritage and community. Yet within this urban fabric lies a hidden vulnerability, known as Mokumitsu. They are densely built wooden neighborhoods from the last century that no longer meet seismic standards. During earthquakes, they act as disaster multipliers, where a single event can ignite multiple fires that rapidly spread, triggering chain reactions across entire communities. We witnessed this devastation in the Great Kanto earthquake in 1923, the Great Hanshin Awaji in 1995, and most recently the Noto Peninsula earthquake in 2024. These prolonged firestorms led to over 100,000 deaths. Looking to the future, Japan predicts that the Nankai Trough Megaquake, even larger, may strike within the next 30 years. Today, the threat remains. Wood feeds fire, tight spaces accelerate the spread, blocked routes trap families inside and rescuers outside. So we started looking into nature to find a solution that traditional engineering cannot provide.
So we asked ourselves, how can we design a retrofit for existing wooden buildings without behavior change, where its job is to buy time after a fire outbreak during the quick or natural disasters?
This is where TAIKA comes in. Through this project, we want to explore a more sustainable and environmentally friendly coating rooted in biomaterials. Conventional coatings are usually chemically heavy and often toxic. When they burn, they release harmful toxins that create a second wave of health risk for both human and our environment. So we began to conduct a series of experiments to find a potential material. Eventually, we found our answer in mushroom.
TAIKA is a sustainable fire delay coating derived from fungal substances. On top of that, it will also address other environmental problems hiding in plain sight in Japan. Japan is the world's second largest mushroom producer, generating 469,000 tons per year. Every harvest leaves an enormous byproduct, spent mushroom substrate, or SMS. In Japan alone, over 210,000 tons are disposed annually. Most of it ends up in landfills or incinerated, which contributes to greenhouse gas emissions, foul odours and water contamination. But what if this waste could become a resource?
Chitosan derived from chitin, a natural polymer found in the cell wall of the fungal fruiting mushroom bodies and stems. It has the properties of fire retardants. For silica, we found that SMS in Japan is mostly made of paddy straw and rice bran, which are rich in silica. Natural silica itself is well known for providing a shield as a thin film, and it has a hydrophobic property. So with these properties, we are thinking together, would they provide a stronger protection?
To test this idea, we work at a bench scale in a chemistry lab. To extract chitosan, we first prepared 30 grams of dehydrated mushroom powder for the warm water extraction, boiling in the water at 80 to 85 degrees Celsius for 1.5 hours. To remove fat and proteins, we conduct the deacetylation process with alkaline treatment. After that, it was repeatedly washed and purified water until it was neutralized.
We use dry spent mushroom substrate incinerated at 600 degrees Celsius for 15 minutes in a furnace until it's turned into ash. Then it was treated with citric acid to remove metals and other substances. Then we mixed 3 different chitosan to silica ratios and applied each across multiple layers on the wood samples. Then tested each with a torch estimating to 1200 degrees Celsius for 30 seconds. The results indicates that a silica concentrations of 6.7 gram to 10 gram of chitosan performed best. The coating carbonized and crusted under heat, and the wood beneath remained largely unburned. We also noticed that flame spread was visibly controlled and fume generation was also reduced. So the direction is promising.
As our next step, we are in the process of discussing future collaboration with some big mushroom farms in Nagano, Nygard, and Hokkaido, and Nagashima farm in Yokohama.
Looking further ahead, for the mushroom farmers, what was once a disposal cost becomes a new source of income. For the elderly residents of Mokumitsu who cannot afford to rebuild and legally demolish their homes, protection finally arrives. Without relocation, without renovation, without a single change to the way they live. For the rest of the country, a slower fire is a survivable one. Shielding vulnerable homes means the next earthquake doesn't have to become another firestorm. This is not just a coating. It is a bridge that was built from the things we used to throw away, between Japan as it is and Japan as it could be. TAIKA, natural disasters, natural defenses.